Hi, I'm Shale. In this video, I will show you how to solve a one-dimensional kinematic problem using the guess method. We will review key vocabulary, units, and then work through a real F1 racing example step by step. Here are the major concepts in one-dimensional motion. Displacement, change in position, measured in meters. Velocity, rate of change of displacement, measured in meters per second, is vector. Speed, magnitude of velocity, also measured in meters per second but scalar. Acceleration, rate of change of velocity in meters per second squared. Scalars versus vectors. Scalars have size only, like speed. Vectors have both size and direction, like velocity and displacement. One-dimensional kinematic problems assume constant acceleration, so we can use the kinematic equations. For context, a real F1 car accelerates at about 10 meters per second squared. Now, the method we will use is guess. G for givens, U for unknowns, E for equation, S for substitute, and S for solve. Alright, so this is our problem that we're going to solve using the guess method. So the problem is an F1 car accelerates down a straight 200-meter section of track with a constant acceleration of 10 meters per second squared. At the end of the 200 meters, it reaches a final velocity of 80 meters per second. What was the car's initial velocity at the start of the 200-meter stretch? So first we're gonna list out our givens. So we are given the displacement, which is delta x equals to 200 meters. And then we also have our acceleration, which is 10 meters per second squared. We also have our final velocity, which is Vf, which equals to 80 meters per second. And we are gonna find our Vi. So these are our givens. This is our unknown. So Vi we're trying to find. So now for E, which is equation, we're gonna use the equation Vf squared equals to Vi squared plus 2a delta x. So this is our equation. I'm going to substitute. So to get the Vi on its side, so we need a minus 2a delta x on both sides. So then it's going to become Vf squared, minus 2a delta x, which equals to Vi squared. So we can also write it as Vi squared equals to Vf squared minus 2a delta x. So then we're gonna solve this now, which is the last part of the S for the guess part. So the G was the given, U was the unknown, E was the equation, S, the first S was substitute, and then the last S is solve. So then we're gonna substitute, so then we have our Vf over here, as you can see. So then that's 80 meters per second squared minus 2 acceleration, so 2 times 10 meters per second squared times 200 meters. So then that's gonna give us 6,400 meters per second minus 10 times 200 is 2,000, so 2,000 times 2 is 4,000. 4,000 meters per second. So then Vi squared equals to 2,400 meters per second. So you see how we still have the Vi squared over here. We need to get rid of this Vi squared, so we're gonna square root this. So then that's gonna become Vi equals this 2,400 meters per second. Vi gives us 48.9 meters per second, which we can round off to 49. And that's it. Thanks for watching.